Bismillahirrahmanirrahim. Good morning everyone. Today inshallah we will continue our syllabus starting with Unit 2 Lesson 2. Unit 2 Lesson 2 is talking about wave nature of light. We talked before what is meaning of wave and we know what is the meaning of it. So today in this lesson we will know what is the nature of light waves and what are its properties. Light is a form of energy, and when it reflected from object and falling on eyes, it causes vision. What is the meaning of that? This means that light is a form of energy. We know what is the meaning of energy. So we have many forms of energy, and today we will focus only on light. Light is a form of energy, and when it is reflected from object and falling on our eyes, it causes vision. Because of that, we can see everything around us. From the previous, we can understand that light is an external factor or stimulus that are affected the eyes, causing the sense of vision. When light falling on the object, anything, this light is reflected on our eyes, then we can see the object clearly. In this lesson we will study what? Nature of light wave, analysis of white light, energy of light waves, light behavior through different media, light travels in straight line, and last thing is light intensity or the brightness of light. Okay, let's continue with wave nature of light. We talking about light. What is the meaning of light? This is the first definition in our lesson today. It is an external factor which affects the eye, causing the sense of vision. This is the first definition. Nature of light waves. We know that we have types of waves. In this year we talk electromagnetic waves and electromagnetic waves, transverse wave, it is a kind of it. Transverse wave, we know that transverse wave is forming from crest and trough. So when we say that light waves are electromagnetic transverse wave which can travel through free space, because it is electromagnetic, it is don't need media to travel through, with velocity equal 300,000 km per second or 3 times 10 power 8 meter per second. So light wave are formed of crests and trough because of it is a transverse wave. What is the speed of light? What is the meaning of speed? Speed means distance covered by light in 1 second. So the speed of light, it is the distance covered by light in 1 second. In this lesson we have a problem about distance. How can we calculate distance between Earth and Moon? This is a problem. Are you ready with me? Calculate the distance between the Earth and the Moon. If you know that the reflected sunlight of Moon's surface reaches the Earth after 1.3 seconds. So I told you before, if we see any problem we have to focus on what? On the information. We have to read the problem well, then we have to take the information from the problem and write it first, and then we have to write the answer. First thing is speed of light. We know the speed of light means distance per time, distance over time. So the distance, we calculate the distance from this law by taking speed of light time. Speed of light through vacuum, it is 3 times 10 power 8 meter per second. Then the distance between the Earth and the Moon equal 3 times 10 power 8 times 1.3 equal using your calculator by many steps. Don't write the answer directly, because I told you before each step had mark. Okay, then we write steps. And finally, don't forget the unit. He need the distance, so the unit of distance by, we measure the distance by kilometer here. Okay, then what is the visible light? Visible light, it is one of components of electromagnetic spectrum of wavelength range between 380 to 700 nanometers. Here you can see this is many waves of light, or many waves of many waves here, microwave, radio wave, gamma rays waves, x-rays. Our visible light lies here between 380 to 700 nanometer. This is the visible light. Visible light discovered by who? We have some information here. Al-Hassan ibn al-Haytham was the first scientist who established the science of light, discovered the pinhole box which helped in developing the optical camera, explained how vision occurs. As you all know, what is the main source of light on our earth, on our planet? We know, right? Yes, is sun. This is the main source of light energy on the earth's surface. If we want to analyze this white light, or if we want to spread our white light, what we can see? When we split the white light into 7 colors, it is split into 7 colors. These 7 colors are called spectrum colors. So the white light analysis into spectrum colors. What are spectrum colors? Spectrum colors, how can we see it? Imagine with me that you have CD. Yes, CD of the computer which you use in lab or at home. If you put a compact disc CD on your table, faces sun rays, what can you see, or what can you observe? Yeah, you will observe the formation of 7 colors, like here, many colors you can see on the surface of the CD. This is due to what? This is due to the analysis of white light into 7 colors. What are these 7 colors? These 7 colors I told you before, it is called spectrum colors. Spectrum colors, you took it before in prime 5 or prime 4, I didn't remember. White light, when it is fall on glass prism, it is analysis into 7 colors here, like you see, from the apex of the prism and to the base. From the apex of the prism, it is red, orange, yellow, green, blue, indigo, and finally violet. So the 7 colors, or the spectrum colors, starting from the apex of the prism to the base, from red into violet. Similarly, when the white light falls on the triangle glass prism, it is also analysis into 7 spectrum colors, as we see here in this picture. What is the difference between red and violet? Each one and each color from these 7 colors has its properties. We will take only 7, the first one and the last one. The first one, it is red, and the last one, it is violet. Red, it is the lowest deviation. What is the meaning of that? It is because of what? Because it is close to the prism apex, and it is the lowest frequency. It has lowest frequency. It has a low frequency because it is near to the apex of the prism. Then it is the longest. It has long wavelengths. It has long wavelengths. Then violet. Violet, this is the first one, red, Second one is violet. Violet, it has the highest deviation. Because of what? Because it is close to the prism base. It has a high frequency. It has short wavelengths. So what is the lowest deviation from these 7 colors? It is red. What is the shortest wavelength from these 7 colors? The shortest wavelength, it is violet. Okay, we have many questions here, and many questions as complete or choose. So please focus on this and learn this well. Then we will talk about energy of light. Energy of light, a German scientist called Max Planck proved in 1800 that he proved what? He proved that the energy of light waves is composed of energy quanta known as photons. So energy of light composed or components of photons. The energy of photons, we give it letter E, is directly proportional to the frequency of the light wave. What is the meaning of directly proportion? Directly proportion means when the frequency increases, the light wave increases. Okay, so proton energy, this is the symbol of directly proportion between photon energy and photon frequency. When it is photon energy increases, photon frequency increases. When it decreases, it is decreases. So we called it, they have directly proportional. What is the photon energy? How can we calculate it? We have a law of photon energy. It is equal constant time photon frequency. What is this constant? Is this constant? It is a constant value. It gives us in the problem, so we can use it in the problem. The constant value is known as Planck's constant. Planck's constant due to the Planck scientist. Okay, photon energy is Planck's constant time photon frequency. We have exercise here or problem from this picture. Which one has a greater energy, the photon of red light or the photon of violet light? Given that the frequency of red light is less than the frequency of violet light, who knows the answer? Read the question well before answer it, and then take your time. Okay, I'll help you. The answer is the energy of photon of red light is smaller than that of photon of violet light. Why? Because the energy of photon is directly proportional to the frequency. I told you before about their about the frequency and photons energy. What our real life application for uses in our life? The real life application for uses of light in our life. We use light in where? We use light in everywhere. Light is used in home decoration. Like what? Like spots. Yes, spots light to illuminate artifacts or surface. Ornament lamps that bring happiness and joy to the places. Yes, in our home, in receptions. Stand lamp that concentrate light for reading. This is in your home, in your office. Then light behavior through different media. How the light travel? We know that light travel in straight line. We took it before. It is a previous information. Light transmits through different media with variable degrees. What is the degree of light? We classification the media which light pass through it into three types. First one, transparent media, translucent or semi-transparent, and then opaque. What is transparent, translucent, and opaque? Transparent means it is a media which permits most of light to pass through it. Like what? Like a clear glass of window, air, pure water, a glass cup, clear glass cup. All of these things are called transparent medium. So transparent medium are objects which light can pass through it easily. Most of light can pass through it. Object can be seen clearly through transparent media. This is transparent media, like air, I told you, air, pure water, glass. I want you to know this information. By increasing the thickness of transparent media, the quantity of light that passes through it decreases. How? When we have many sheets of paper, clear paper or glass, when we have many sheets of a glass or clear plastic and put 1, 2, 3, 4, 10 sheets over themselves, how can you see? You can see like before, like you using only one sheet? Of course no, because by increasing the thickness of transparent media, the quantity of light which pass through this media will decrease. Then we have give reason here. Although water is a transparent medium, we can't see fish at the bottom of the river Nile. When you pass beside the river Nile, you can't see fish underwater. Why? Because the thickness of water at that point which you can see it is large enough to prevent light to pass through, because the thickness of water is thick, so we can't see fish clearly. Okay, understand it now? Okay, this is the first type of medium. It is transparent medium which permits most of light to pass through it. What is the second type? This is the second type. It is called translucent or semi-transparent. Translucent medium, it is a medium which permit only a part of light. A part of light only can transmit through it to pass through and absorb the remaining parts. How? Imagine with me that you have a tissue paper or one paper of your notebook. Okay, you can see through it easily. You can see all the light which fall on it. Of course no. Why? Because it is translucent or semi-transparent, because a part of light can absorb this paper, can absorb it, and the remaining you can permit, so you can see it. Again, translucent media, it is a media which permits only a part of light to pass through and absorb the remaining part of light. Examples of translucent, it is flint glass, tissue paper, and opaque flint glass and tissue paper. Third thing we talk first type transparent, second type translucent, third type it is opaque. What is opaque? Like your hand. When you put your hand in front of your eye, you can see what is behind your hand? Of course no. Why? Because your hand is opaque. All the light falls on your hand absorbs it, so you can't see through it easily. opaque medium. The opaque medium, it is the medium that doesn't permit light to pass through it at all. Object can't be seen through opaque medium. What are the examples of this opaque medium? Plant leaves, foil paper, milk, box, metals, wood, cartons, human skin, your hand also, black honey, because it is dark. Okay, then we have a give reason. Give reason. Carton or any type of these things is an opaque medium. Why? Excellent. Because it doesn't permit light to pass through and object can't be seen behind it. Good. We have information, enrichment information, solar and lunar eclipse, which you took in prime 6, can be explained according to the traveling of light in straight line. So light is travel in a straight line like here. Okay, here I have an exercise for you. Compare between transparent, translucent and opaque media. What is the point which you have to compare between? Definition and example. You know what is the definition of transparent medium, translucent or semi-transparent media, and the last thing is opaque media. And also you have to write examples here. Good. Then return to our lesson again. Light travels in a straight line. Light propagates or travels through transparent media in a straight line whose thickness can be controlled. And this point we explained it before. Okay, by increasing the thickness, what happened to the light which you can see? It is decreases. Here we have an activity to determine the propagation of light in a straight line. How we know that light is travel in a straight line? Here we have an activity, we have a material and tools. What are the materials which we need? 4 cards, pieces of clay to fix this paper, a white paper plate, and last thing is light pen. How can we do this activity? Make identical holes in the 3 cards A, B, C. Make identical hole in sheet A and B and C. Then fix 4 cards by using the clay on the white paper plate here like this, keeping space between them. Then using light pen to allow light to pass through the hole in card number 1 or card A. Then repeat the previous step by replacing the cards with other have wider hole, using a wider hole or make a wider hole in the other sheet. Here, what can you observe when we repeat the experiment by using the wider hole? Here the light ray passes through the hole in a straight line and a light spot is formed on the card D. When you observe here on card D, you can see a spot of light. Because of what? Because light travel in a straight line. Then move the card B to the left. What you can observe? The area of the formed light spot increases by increasing the size of the hole. Last thing, the hole spot on card C disappear. Why? Because it is formed on card D. Our conclusion from this activity: light travels through transparent media in the form of a straight line whose size or thickness can be controlled.